Welcome back, learners. So now we're going to go to our second concept for this lesson. So that is now the density and the states of matter. So to start, we need to know that we have three different states of matter, and we need to be able to fit in there we need to know how density fits in those three different states. So now to start, solid, liquid, and gases, those are different from each other. We know that they're different from each other because of the distances between the particles in each respective state. We know that in solids, the particles, they have smaller spaces in between them, whereas in liquids, the spaces is slightly larger than as compared to the solids. However, in gases, the spaces between the particles are way bigger than those as compared to the liquids and the solids. So that's how they are different. And also in terms of the movement, the particles in a solid, they vibrate, and then the particles in a liquid and gases, they move chaotically around that particular container. So then, the particles in gases are much further apart than the particles in liquid or solids. We know because of the spaces between them. Now, what does this mean for density? Remember we said that when a particle is heavier, it means it is more dense. So when we are looking at the solid, the liquid, and the gas, if we were to compare now the density of the gases with the density of the liquids, you'd notice that because the solids are slightly heavier than the gases, so that means the solids have more density. So solid materials have a high density, and that explains why they cannot be easily compressed. Furthermore, the particles in a solid are tightly packed and cannot be squeezed closer together into a smaller volume. So now those ones are the particles of a solid. In addition, when we're looking at liquids, liquids are also very dense, and the density of a liquid is roughly the same as the density of the solid, as of the solid state of the same substance. Remember, they are slightly similar because of the spaces between the particles. The spaces between the particles in a liquid are slightly larger than the spaces of the particles between the solid particle, or the solid matter. So now, this is because their particles are close together even though they are not locked into a fixed position. So now those ones are the liquids. The particles of a liquid are close together even though they are not fixed they are not locked into a fixed position. They can be able to move around chaotically within that particular container. So most liquids cannot be compressed into smaller volumes. This is mainly because of the spaces between the particles. Now, liquids are slightly less dense than their solid states, but water is an important exception. We are saying that liquids are slightly less dense than their solid states. However, when looking at water, that is an important exception. Have you ever wondered why your ice cube floats on water in your class? So whenever you pour a glass of water and add ice cubes into it, those ice cubes, they float on top of the water. Have you ever wondered why that happens? So the reason why that happens is the solid state of water is less dense. So remember, the solid state of water, which is the ice, it is less dense than the liquid, because in the ice, the water molecules are packed in a unique way. So in an ice or in a solid, the water molecules are packed in a unique way. Then, the image on the right, as we can see here, it shows how those particular substances are packed in that certain way, in that unique way. You notice that when you're looking at the solid, there are spaces between the particles. Whereas when you're looking at the liquid, the spaces are smaller than those in a solid state. So now the same water molecule, as we can see, has been shown on these two pictures to show that there is a difference in terms of the arrangement of the particles, and because of that, that's the reason why solid can be able to float on water, because of the spaces between the solid, which in this case is the ice. Now, when you're looking at gases now, gases are not very dense at all because of the large spaces between them. Remember that the gas particles, they can fill up the entire container, and because of that, they are not going to be very dense at all. Now, this means they contain a small number of particles in a large volume. So whenever you have a certain container, we have a small number of particles of gas in that container, and then the volume in which those gas particles are in, it is very large as compared to the number of particles. So this is why gas particles can be compressed and their particles can be squeezed closer together to fit into a smaller volume. You know that if you have an empty container, it's not really empty. There are gas particles there. You can squeeze that container and make it smaller, and the gas particles within that particular container will still be able to fit within that smaller container. So because of the spaces between the particles, it makes the gas particles to be able to fit in the smaller container. So now, when we look at our next concept, which is now the density of different materials, we looked at the density and the states of matter, where we discussed the solid, liquid, and gases, how different are they in terms of their densities. Now, when we're looking at other different materials, how is that going to be helping us? So to begin, we need to know that it's very difficult to compare the densities of three states of the same material. So why is that difficult to compare the densities of three states of the same material? That is because that material would have to be at different temperatures to be in different states. When we take water as an example, the H2O, it needs to be in a solid state, it needs to be in a liquid state, and also needs to be in a gaseous state. And all of those particular states, they have different temperatures. And because of that, we can be able then to compare three different materials such as sand, water, and air, because we don't have to have them in three different temperatures because they are different. So then, we also need to know that not all liquids have the same density. The type of the material affects the density. So when you're looking at water and when looking at mercury at room temperature, those are two different liquids. Even oil, for as an example, those are different liquids. And because they are different liquids, they not all have the same density. Right? So then, when two different liquids of different densities mix, so when we are mixing two different liquids and each of those different liquids have different densities, they will be immiscible. So what do we mean by immiscible? That means we're going to have two layers of that particular mixture. We're going to have a certain liquid on top and the other one at the bottom. You've probably seen that when you're mixing oil and water, the oil sits on top and then the water sits at the bottom. Now that should tell you about the density. So now, for an example, we know that oil floats on water for two reasons. Why does oil float on water? Number one, a cup of oil has less mass than a cup of water. Remember we said the substance that has more mass, it is going to be more dense. So then the oil is less dense than water. So why? Because the cup of water is more dense, or it has more mass than the cup of oil. Now this makes oil float on water like a cork or an air-filled rubber duck which floats on the surface of the water. Here we're talking about our bath toys. So the ducks that we are using when we are bathing to play around there in the bathtub, so they float on water because they have less mass as compared to the water. Now the second reason why oil floats on water is that oil does not dissolve in water. Now the oil molecules cluster together and float on the surface. So the oil molecule, they cluster together and float on the surface. So instead of it dissolving in water, they cluster together and float on the surface of the water. If a large amount of oil is poured into water, the oil will spread out and form a layer of the surface on the surface of the water. So that means that can be regarded as a heterogeneous mixture because you're going to have two different layers in one particular container. Why? Because they have different densities. So when two substances that are in the same container but do not mix, in the case of oil and water for instance, they are going to form two layers. There's going to be a layer on top and the layer at the bottom. So in a certain sense, water and ice also form two layers. So we remember the example that we made about ice and water when you're pouring a cup of water and adding a few ice cubes on that particular cup. The ice cubes are going to float on water. And because there's going to be that distinction, we can then say that there's two layers that is being formed. Now we need to now know which layer will be on top. Is it the one that is more dense or the one that is less dense? Remember, when a substance is more heavier, it means it is going to be at the bottom. It means it's more heavier. And the substance that has less mass is going to be at the top, meaning that it is going to be less dense. Now, the density of a material depends on how tightly packed the particles inside the material are. So the density, it depends on how tightly packed the particles inside the material are. So the more tightly packed they are, the more dense we say they are. So if a particle or if a substance has particles which are tightly packed within it, we can say that that particle or that substance is more dense. Again, a gas will expand to fill whatever space it is in. In a larger container, we still have the same number of gas particles, but now they are filling a much larger space. So for an example, if you were to take 10 gas particles and put them inside a small container, they're going to expand and fill that space that they are in. At the very same time, if you're to increase the size or increase the volume of the very same container into a bigger one and take the very same number of gas particles, we said 10, and put them in that bigger space or in that bigger volume of a container, they're going to still expand and fill that entire space in that container. So for this reason, the gas particles can be squeezed or compressed together, and then can also be able to fill the entire space that they are in. So learners, I hope that I've shed some light on what density is and how to calculate and how to actually talk about density of different materials. I hope you had as much fun as I did. Until I see you next time, bye.